Okay, gentlemen, I'm responding to some of the questions I've asked and some of the questions you guys have asked back. Got this beast on. I'm going to do a frequency response scan of it, and I want you guys to tell me what you think about it. I've been playing with this one too. This is just the other one. Forget about that. Okay, let's do this. Let's just do a frequency response scan, and you tell me what you think. I think the transformer is going to make it, but let's do something here. Start. And it says, is the reference level okay? Well, you go over here and you see what the reference level is. That's 0.81 watts. So, you know, we can raise it a little bit. Let's raise it up to the suggestion was made 1 or 2 watts. What about that? 1.26 watts, just to get a frequency response scan of it. See, at that power level, it's about as flat as DC. See, there's 20 hertz. 20 hertz, 0. It's flat at a watt. All the way up to at least 20 kilohertz. This thing says it's going to stop frequencies 30 kilohertz, but it usually stops a little short. It stopped at 20. So it's 20 to 20 kilohertz. That's pretty flat, isn't it? Now I have to start new scans each time so I can adjust the level. And then we say, okay, that was at 1 watt. Let's try 10 watts. So we go back over here, and well, there's 6.52. Okay, there's 8 point whatever. Let's try it at 8 watts. Okay, there it is on the, there's the kilohertz. There it is. That's 8 volts, which happens to be across 8 ohms, 8 watts. There's its THD, 0.07%. Pretty amazing, huh? 1 kilohertz. And let's look at the frequency scan, the frequency response there. And then I'm going to stop, keep this one really short, and see what you guys think. See, it's down about a dB, just a little over 1 decibel at 20 hertz. Now let's do one more. So whatever this is telling me about the transformer, it certainly isn't taxing the transformer. I mean, running it at 1 watt and 8 watts has got to be pretty much nothing. See, it's down just a little bit at 20. Okay. Now, excuse me. The way we do this is we start another frequency scan, and then you say change this to 5, keep it at the same. Say start. Then we've got to set the reference level. The way we do that is I turn it down. You take it this 8903, if you're familiar with it, you take it offline, then you say amplitude 6 volts. Let's set it really nice and high. Now we can run this thing at pretty much, what about 28 watts? Because if I go 10 more dB, it'd be 280 watts. But let's just do it at 28 watts, 28.78 watts. Let's do it. Okay. And then we get this. See, now we're down 5 dB at 20, and it comes up quickly, 20, 30, 40 to 50 hertz, and then flattens out again. Okay, with that in mind, Would you call that a transformer issue? Surely we're not taxing that big transformer at 28 watts, are we? What do you think? I want to go ahead and post this one. And tell me what you think. Well, I'm going to record a few other things. Just at the 28 watt level where we do see it drop, this is the screen voltage. It's just a hair below 800 volts. Ideally it's about 750, but I can't get it dead center. My meter is very accurate. Okay, so let's watch this guy. We're running it back at the 28 watt level. And when I say okay, we go right back over here. See it drop, 20 volts. That's the screen volt. See it rise slightly. Drops just a little bit on the really low frequencies. But I don't think 20 volts is the problem. I can hear it at about a kilohertz squealing. See, our screen voltage is stable. Okay, so that's that. Now let's do it again with a bias voltage. And of course here's our same response as we got a while ago. I'm running new scans each time, that way I can set the voltage. The way this Pete Millett program works, thank God for that he wrote them for us, but I can't change the reference level in here, the generator level. It doesn't work. So what I have to do is take the 8309 offline and then set the voltage and then say okay, the reference level is okay. The problem is when you come back and try to run it the second time on the same program running, it resets it back to its default value, so you have to start another one. But that's no problem. Thanks, Pete, for doing this for us, because you'll see when it says reference level okay, see it went back to the 0.81 watts. So what we're going to do this time is take it offline, amplitude 6 volts, and then jump back up to the 28 watts. Now we're going to monitor bias voltage. So we got to reverse our polarities here, making sure we don't get too close to this rattlesnake. Put this guy on 300, and the bias voltage is right there, pretty much dead on 100 volts. Okay, let's see what happens. I have to start it and run over that quickly while it's still at 20 hertz. Let's see. Okay, bias voltage. Steady as a rock. Well, it rises, I think, ever so slightly. Like, I don't know if it's rising or not. No, it's steady. So my screen voltage and my bias voltage is pretty much rock solid. And at that power level, so is the plate voltage. Okay, I'm going to take the meter off. A little dangerous working with one hand, I suppose. Yeah, the plate voltage, if this thing doesn't overwhelm it, the light in that thing seems to overwhelm but there it is right there. Just a hair over 2700. There's no use in running it again and showing you that. That one is rock steady too. So my plate, screen, and bias are steady. What do you think? Still think it's a driver board. The transformers aren't perfect, but seems to be something else.